Alright, welcome back to part 2 of chapter 4 of the gearbox for SketchUp for Engineers by Firestarter Graphics and Engineering. This has been a really fun course to teach. I'm grateful for it. It helps me learn and understand better. I'm definitely not perfect at it. And it also helps me teach others. And it's also a fun way to have fun, if that makes sense. Anyway, alright, this is what we did last time. We created this, and now we're going to create these flanges on the side. And I'm going to show you how to do this. Let's zoom in a little bit. This, wow. Okay, there it is. This fillet by hand. Now most fillets, I don't want to say most, depends on who's welding it or how it's done, but it's usually about a 45-degree angle, between 30 and 45. So we're going to use the follow me tool to create this. That is our goal. Now I've done it before and it was a little complicated, but I think we can do it. So let me definitely zoom out. Okay, that's good. So let's work on building that flange. Let's find where placement is. So I think it's right here. Nope, the diameter is 1 inch. Wow, that's interesting. Diameter, but yet over here we're using radiuses. Alright, very odd. Okay. Anyway, let's look for hole placement. Okay, so we're 3/4 of an inch in from this side here, and about the center of this. So okay, I hope that is enough. Okay, hit T for tape measure. Now we can't grab a corner here, so we have to grab one of these flat lines, grab it, and then come up to the center here. And then we're going to, what was 3? Oh, extrusion of, no, it's down 3/4 of an inch. Okay, thought I read that wrong, but I didn't. 0.750. Okay, that's where it's going to go, and it's a 1/2 inch radius, and it's 1/2 inch thick. So circle, 48 sides, plant it right at that intersection, right up this line, or this line, it doesn't matter, and we want a 0.5 radius. There we go. Now, before we do the extrusion, we need to see how thick this is. Okay, so this has a tolerance of, wow, plus or minus 5/1000ths of an inch. So we have 0.57 for the diameter, so half of that. Calculator, let's see, 0.575, divide that by 2, so we're looking at 0.287. Okay, 0.287. So sure, there, 0.287. There we go. Now, is that hole all the way through? It is. So this needs to be pushed all the way to the face, like that. And this one needs to come out 0.5. There we go. Now, before we even do that, if we highlight everything like so, you know what, before we even do that, let's do this. Highlight all that, hit M for move, click Control, and we want to go hit the right button for red. We're just going to move it right to the face, constrained on that face. Okay, so now we've got those two. Perfect. So push, pull this one to right there, and then we can double click that one to do the same. Then we can bring this one out 0.5, and then we can double click this one. Now we probably could have copied this feature over. We would have just had to delete some faces in there to get the circle to go through. But it's just as easy to do what I just did. So let's go ahead. Do I want to delete the guide? No, I kind of want that guide. Okay, so let's make this chamfer. We have, I mean not chamfer, this fillet. It doesn't tell us, or does it? Yes, it does. Typical. So it's a 0.125. Okay, let me see how I want to do this. I want to hit T, and I want to hit the right arrow because I want to go along the red axis, 0.125 inches. Okay. Now what I want to do is hit L for line, go along the intersection until there. Okay. Now I want to make it 45, which means if this is 0.125, I have to go up 0.125 along this as well. And then we're just going to connect them. And that'll make a 45 triangle. Okay. So now what we want to do is use the follow me tool. So let's select our path, which is right here, then select follow me, and then click the triangle. Perfect. You guys see how that worked? Spacebar to unselect. Now we have this fillet. What we can do is mirror it. So hit M for move. Oh man, this is going to be tricky. Let's grab it right here at the intersection. Control. Okay. Hit right for red. And click it right on that face. Okay, now you're going to notice it's on the inside. Right? And it's backwards. So how do we fix that? Well, it's easy. Hit the scale tool, and about the opposite point, grab this and bring it out and type in -1. Boom. That will, look at that. Perfect. That will bring out that chamfer. Let's see, look at this. Aren't we doing good? I'm excited about this part. I don't know if you are, but I am. Okay. Now is a good time to save, so I'm going to pause and save real quick. Alright, I went ahead and saved. So, what should we work on now? Let's look. Might as well put these holes in here. I don't know if they go all the way through. I cannot tell. Oh, nope, they don't. They're not countersunk. What are they? I don't know the word I'm looking for. Where this bore... Here, I'll show you. Okay, this bore is smaller than that one. I guess it could be considered a countersink or countersunk, but does it even show us? Okay, yes it does. Each hole, okay, it's okay. Trying to figure out how to read this real quick. Okay, so the diameter is 0.107 with a depth of 0.432, and then we're going to 6-32 UNC. Alright, so I went and looked up what 6/32 UNC means. It actually means Unified Thread Standard. What the 6 means is a number 6 diameter, 32 threads per inch. But what does a number 6 diameter mean? It actually means that it is a 0.138 inch diameter. So in our case, we need to do 0.138 divided by 2. It tells us it's a 0.069. Man, okay, 0.069 for this one. I need to write this down. Okay, so I went ahead and divided out the numbers. I've got 0.069 and then 0.053. So let's find our hole placement for those. We've got, I cannot tell, I think it's 3.5 between there. Okay, and I want to say that's enough. So take the center from here and we're going to 1.75. Yes. Okay. So let's go ahead and do that. So we're going to, T for tape measure, we're going to go right along the center till there. And then the line, boy, okay. So from here, it's over that way 1.75. That way, 1.75 this way. And then we need to, let's draw a line right here. We just need it as a reference line, T for tape measure, along here until we get that. So the reason why I have the line is so that I can find the middle of this without having to do any crazy, well, it's not crazy maths, but I just don't want to do any maths. So T, tape measure, bring it down to here. Okay, now we have where we need to be. Now, the first hole is the diameter of this one, which is 0.053. Okay, and it's, we're not going to worry about the depth yet. 0.053. So, circle on here, 0.053. Okay, perfect. Now I'm going to click it. I'm going to hit move about its center, control, bring it down. Okay, now I've got both of them clicked. M for move about its centers, control, bring it right to the intersection, and call it good. Okay. Actually, I just did more work than I needed to. Control Z. Let's finish one hole first and then copy it over. 0.069 for the next hole. 0.069. Okay. Now, move, control to make a copy right there. Hold shift. Whoop, whoop, whoop. Control Z. Hit spacebar, but it's still selected. Now hold shift. Click and drag a little marquee around it. Hit M. Zoom in. Control there. Whoops. Wow, what did I just do? Alright, bet. Alright, you know what? One little circle. Two little circles. I'm just getting tired, I bet. Okay. There we go. Right on the inner section. Right there. Okay. Now, what we want to do is we know the first hole is going to have a depth of 0.432. Alright. So the first hole, this one, is going to have a depth of 0.432. Now we're just going to double click here, here, there. And then the next one, we have a depth of 0.276. So, push-pull 0.276. Okay. Oops, too far. There we go. Okay. That seems like a very long depth for that, but it matches our photo. So, it matches our working drawing. Anyway, let's go here. Let's go to X-ray. Just so we can see. I'm going to hit spacebar, edit, delete guides. How are we looking? Looking pretty good so far. So, okay, one last test. Right click, make group, and it's not a solid. I wonder why. Could it be double click inside? Let's get rid of that line, group, huh? Alright, let's go to solid inspector. External faces, 48 of them, eh? Oh. Didn't like. For some reason, it did not like. Wow, it didn't like that one, but it really liked that one. Alright, so I'm going to close it. Let's go ahead and hit Control Z. It might not. I don't know why it doesn't like it. I'll have to figure that out later. It might not be touching, or it might not be closed. Here, let's see. I don't know. Anyways, it's not important right now. We will figure that out later. But it just does bother me that it's not a solid. So hold on. Okay, I think I figured it out. If we're in X-ray mode, look at the back of this face of our fillet versus this other one. This other one literally looks like it needs to be closed off. So if I hit line, let's go from this vertex straight down to there. It makes a little, it's not what I'm looking for. Huh. I wonder why when that one copied over or was created, what is so different versus this one. Looks like it's something to do with maybe the placement of it. I don't know. Well, yeah, because the end of that circle is right there. Somehow when I pushed this one over, it became part of that. But I don't know how. Super strange. It actually became part of that geometry. So what if I want to delete that? Okay, so now it looks the exact same. Okay, let's see what happens. I've never experienced that before. Group. Okay. Surface border. Alright. Info. Edges. Okay. Some areas cannot be, okay, let me see, info. Edges that form the border of a surface or a hole in the mesh. These cannot be fixed on it. Manually close the mesh and run the tool again. Bet. So somehow okay, so just drew a line over. I don't know if that's going to close the mesh off or not. Internal faces. Fix. No errors. Everything is shiny. Alright, Control Z. Okay, so I'm curious to see where that internal face, X-ray, right there. So it must have created an actual, oh, it did. When I deleted that off, okay. Delete. Let's see if that fixed it. Solid group. We're solid. 16.602 meters cubed. So density is equal to mass over volume. So mass is equal to volume multiplied by density, and the density of cast alloy steel, I don't know. Go Google it, you'll find out. Multiply it by this volume, you'll find out the density. But I mean, this is a freaking huge gearbox. This would be something like a cruise ship. Okay, but I'm happy with this solid. Now, hopefully you guys learned something as we experimented with that. Okay, so X-ray, everything is looking good. That's what we want. I don't know why when we created it here that did what it did, but when we copied it, it literally came over here and removed, and when it joined, it like literally erased some of this mesh, some of this geometry here and merged with it. Really strange. Maybe something to do with the scale tool. I don't know. Anyways, we're doing good. So, part 3, we'll go ahead and finish with these flanges and using solid tools, or we could even use just regular. No, solid tools will be quicker because we'll just draw a drill bit, rotate it around, and we'll go all the way through, and we'll just delete them all in one hit. So, okay. Again, thank you for watching. This has been a blast, and I will see you in part 3.